Welcome back to BAS 120. We're going to walk through Chapter 4, Descriptive Statistical Measures. How can we use statistics to describe our data? So I think of this as if somebody came along and said, I don't know anything about the data. How would I describe that to them? So some of the topics we're going to cover is we're going to talk about the difference between a population and a sample. We're going to talk about some of the measures of location. Where is our data located? Where is the center of our data? We're going to talk about measures of dispersion. What's the range of our data? We're going to talk about measures of shape. What's the shape of our data? We're going to talk a little bit about grouped data. We're going to talk about how we measure if there's an association between two sets of data. Is there a correlation or a relationship or an association of those two sets of data? We're going to talk about how do we handle if we potentially have outliners in our data. And then we're going to talk about how do we take this descriptions and do some sort of statistical thinking. How do businesses or other folks use the data to actually help them with actions? So the population is all items. A sample is a subset. I think most of us are familiar with that. The population would be the big circle. Sample would be the small circle. Now, an important thing to understand in terms of terminology as we get into statistics is when we talk about a population mean or a population standard deviation, those are called parameters. So things that describe the population are called parameters. Things that describe the sample are called statistics. And the whole purpose of what we're trying to do is we're trying to use these statistics to gain an understanding about what the parameters are. Or more simply said, we're trying to take a small sample to understand the population. Couple of notational terms, and you may want to keep these in your back pocket because they'll be useful as we go through different formulas or different terminology. So first you have a mean or an average, and if we're talking about the population, we use the mu symbol. If we're talking about a sample, it's X bar. So they're both mean or average, but one is the mean of the population and one is the mean of the sample. Same thing for standard deviation, which is a measure of dispersion, which we'll get into in a minute. Sigma is the population's standard deviation. A small s is a sample standard deviation. If we're talking about size of the population or size of the sample, capital N is for the population, small n for the sample. And then another thing to think about as we go through statistics is we have a set of statistics and formulas for our numerical data, but then for our categorical data, we generally talk in terms of proportions. So proportions is where I have success or failure. I either make or don't make it. So a proportion is normally for the population is signified by the symbol pi, and a small p is for the sample proportion. And this is also handy to understand. This symbol means that we're summing up everything within that bar. So that's just some quick notation to understand. Now let's get into some measures of location. So let's take an example. Let's say we all took a test exam and no one knows the data, and the instructor might try to explain what that data was like to the classroom. And one thing they often do is they try to give you some measures of location. What is the mean? Where is the center of our data? What is the mean? What is the average? Three types generally of locational data measures. The mean, which is often called the average. So what I've done here is I've given you the measure, a short description, and then since we're using Excel in this course for a lot of our statistics, I've given you what the function is within Excel to utilize that. So you have the mean, the median, which is the middle score, and the mode, which is the most frequently scored score. And these are the three main measures of where our data is located. Now let's talk about measures of dispersion, because we could have three sets of data as we have here, A, B, and C. All of these are going to have the same mean, the same median, the same mode. They're all right around there, but they're very different curves because notice they have very different ranges. So it's very similar to a test. Everybody might have had an average of 80, but one class might have had a range of 70 to 90. Another class might have had a range from 20 to 100. Very different sets of data to try to understand. So when we measure dispersion, 3 or 4 ways we can measure it. We can talk about the range of the data, which is the min versus the max. We could talk about the standard deviation, which is a measure of how far away from the mean is our data. How much deviation is there away from the mean? We sometimes put those into what are called standardized scores or z-scores for a normal curve, and we're going to get more into this as we get more into future chapters. We also sometimes talk about the coefficient of variance, which is the standard deviation divided by the mean. Now, the whole purpose of these dispersion measures is to tell us, what the range or how dispersed our data is. And there are examples of each one of these in the example videos. I want to take a moment and just give you a couple of the equations for these, so you just have and walk through sort of the statistical thinking behind them. So let's talk about the standard deviation of the population. So remember, this is our standard deviation of a population. We sum up all of these. So what we're doing is we're taking each test score, comparing it to the mean, and then we're squaring it. And the reason we're squaring it is if we compared all of these to the mean, our positives and negatives would offset each other, and this would sum up to 0. So we would accomplish nothing. So we square them so that we make them all positive numbers, and then we divide by the number of scores we have to basically get an average. And then since we squared all of these, we basically undo the squaring by taking the square root. Now, you're going to have statistical tools that'll calculate the standard deviation for you, so you're never going to have to go through all of this by hand. But I think it's important that you have an intuitive understanding of what's going on. What's going on is we're taking each one of our scores, comparing it to the mean, we're squaring it so that we get a positive number, we're dividing it by the number of n, the number of scores we have, so that we get an average, and then we're doing a square root to basically undo our square sign. Standard deviation of a sample works almost the exact same way. The only change is because we're going to divide by n minus 1. And the reason for that is this is called a degree of freedom, which we'll talk about in more detail in the future. But basically what's going on here is to make sure our data isn't biased, because one of our parameters is unknown. Basically, we're substituting here. We knew our population mean. Here we're substituting our sample mean for the population mean. So we're taking away one of the parameters, or estimating one of the parameters with our sample, so that we don't unbias it. We subtract by 1 degree of freedom because we substituted a sample in for one of our parameters. So now that we've talked about the measure of location, the measure of dispersion, let's talk about some measures of shape, because our data could be shaped differently. We could have skewness. If we're skewed over here, for example, most of our data is to the right of the mean, we would call that positively skewed. If most of our data is to the left of the mean, we would call that negatively skewed. So that's what skewness is. We could also have kurtosis. That's a measure of the shape of the data. Is it tall and skinny, or is it relatively not tall and a little more flatter? Notice the dispersion of these 3 sets of data is all the same. The range is all the same. 2 key measures of shape: kurtosis that we talked about, and skewness. And there is a description and how you do it in Excel. And then this tells you whether your dispersion is widely dispersed or less dispersed. And most of us aren't going to memorize all of these, but we're going to know how to look them up as we need them. And you're going to see later in this video that with one touch of the button, you're going to get all of these measures of descriptive statistics. Let's talk about a couple special situations of grouped data. Okay, so what's going on here is oftentimes you don't have access to the raw data. Like, let's say you have government numbers that you're using and you just get a frequency distribution table. In those special situations, you're going to take the frequency distribution table and you're going to calculate the mean and the standard deviation that you know, and you're basically going to take each one of your readings times the frequency, add them all up, and divide by n. Again, most of this is to be aware that these situations, and there are tools to utilize for these situations. When you have group data and you don't have the raw data, so you can't give the range, you can take the frequency distribution and calculate your mean and your standard deviations. And all of these are in the book. All these equations, use as you need. The other thing to think about as we get into this is what's called categorical data. So categorical data is where we have proportions. Say, percent of the time we're successful. 1 minus this proportion is the percent of the time we're not successful. So if we had data on the number of on-time deliveries, we could count the number of on-time deliveries, divide by the total, and that would give us a proportion. Or another example, if we had 12 defects for every 1,000 in the sample, the proportion would be 12 divided by 1,000, or 1.2%. All you need to know for now is proportions are going to use slightly different statistical formulas. And we'll go through all of those. But I want you to be aware that there are proportions that come into play, and we'll talk about each one of those different statistics as we move on. Now let's talk about, so we've talked about measures of location, dispersion, shape, group data, and categorical proportions. Let's talk about measures of associations. So sometimes we want to understand the data. We want to understand if two sets of data have any relationships to each other. Are they related? Two key measures we use. There's called a covariance and a correlation. Most of the time you're going to be interested in the correlation of the two, but you can calculate the covariance also, and we go through examples of how to do each one of those. So once again, there's the key measure, there's the description, and there's the tool that you use in Excel. And you can, it's very easy in Excel to go to the data add-ins, and you go to data analysis, and you can see right here there's a covariance, a correlation, a covariance, and we're going to talk in a few minutes about the Descriptive Statistics tool, all part of the Excel add-ons. Let's talk for a minute about outliners. So sometimes we have data where we have some numbers that when we do our graphics or frequency distributions seem to be out of line, or there's several standard deviations away from the mean, oftentimes 3 or more standard deviations away from the mean. Now, it's very subjective there's no formal definition as to when a data point becomes an outliner or doesn't become an outliner. Many people, but it's certainly anything that's 3 or 4 standard deviations from the mean, you may want to do some investigating. Maybe someone typed it in an error. Maybe there's a typo in your data. Maybe there's a special situation that needs to be compensated for. But if you do take outliners out of your data, you want to make sure you document that so that people understand you're not biasing the raw data. So what you want to do is you don't want to bias the raw data, but if you've got data that is an outliner or may have been typed in incorrectly, you want to make sure you're not biasing your results by those outliners. The last thing we're going to talk about in this chapter is what's called statistical thinking. So this is how are we going to use all of this stuff, some of the tools within Excel, to make sure that we utilize this to take some sort of action. So first of all, let's talk about the tools. So the nice part about Excel and other tools is you can highlight your data, or highlight your range, go to Data Analysis Tool. So you go to Data, Data Analysis, and this screen will come up. Go to Descriptive Statistics, and it gives them all to you. Here we've highlighted two sets of data, so you can highlight two. It gives you the mean, the standard, all of the statistics that we've been talking about to describe data. One touch of the button, it gives them all to you. All you need to do is you need to make sure you understand what all of these are, and we've gone through and explained them. So that's probably the tool you're going to use most of the time. You're going to get a set of data, and you're going to say, let me understand this data descriptively. Go to your data analysis, and get descriptive statistics, and it gives them all to you in one-stop shopping. Now let's talk about statistical thinking and what it is. So statistical thinking is used a lot in business circumstances. It's a philosophy of learning and, most important, actions based on the following principles. So the first principle is that our work is interconnected processes. So if I'm working in business, the accounting processes may impact my billing processes, or vice versa. There's an interconnection. If there's errors in my billing, it's going to cause errors in my accounting function. So there's a chain of activities that turn my inputs into outputs, and if all the processes are interconnected. So if I'm building a car, if there's delays or downtimes or process errors in putting the tires on, that's going to affect my quality level at the end of the production line. The second principle is variations give rise to uncertainty, and there's uncertainty in all processes. So there's a sense of randomness. It's like all of us at work. There's some variation in our work. Some days we're more productive than other days. Now, there's variations in every process, in everything we do, because there's some uncertainty. Now, one of the things we'd like to do is understanding these variations and reducing these variations are often keys to our success. So if we have very little deviation in our processes or reduce that variation, that tends to be very, very helpful to our success and understanding what those variations are. So these three principles that we just talked about allows us to do some statistical thinking. There's three key components. First one is we need to think in terms of process. We need to think when there are errors, what is the process that drove that error? We need to understand and manage the uncertainty. And we need to use the data wherever possible to guide our actions and improve our decision making. So let's give a couple quick examples of where folks might use this statistical thinking. So in modern portfolio theory, I don't know how many folks have stocks and bonds, but you can have a mix of stocks and bonds. And what they've done in modern portfolio is they've measured the risk of various portfolios. For example, the risks of different investments. Now, risk, the way they measure risk is they use the standard deviation. That's a measure of variance. More variation, more risk. Rate of return, they've just taken the mean of the rate of returns over the last 35 years, from 1970 to 2005. And what they've done is they've plotted different mix or portfolios of stocks and bonds to measure where is what's called the efficient frontier, or where do I maximize my rate of return at a minimal amount of risk. And for different portfolios, there are different areas on this curve. So modern portfolio theory uses statistical thinking to measure the risk of different portfolios, i.e. the standard deviation, and to measure the return of different portfolios, i.e. the mean over a certain period of time. Another example is in production lines. Oftentimes you'll have an upper control limit and a lower control limit. In here you see these normal deviations. And what this helps management do is understand, when do I just have a normal blip, something that I don't need to become overly concerned about, and when do I have a blip that's so significant that I may need to shut down the production line or do investigations? When do I just have normal variations? Because remember, we're always going to have variations in a degree of uncertainty. And when do we have variation that's significant, at a significant enough level that we need to really think about either changing the process or something like that? So that's the concept of statistical thinking. That's a couple examples. Let's go through the learning objectives for this chapter just to make sure we've covered them all. We talked about the difference between a population and a sample. We talked about statistical notation, measures of location, dispersion, measures of shape, measures of association. We talked about the one-stop shopping with the Excel Descriptive Statistical tool. We talked about how to calculate a proportion. We showed you the Excel correlation tools, which there's lots of examples in the examples. And we've briefly touched on the principles of statistical thinking. That's chapter 4. Hope that helps.